Hi everyone, so today we'll be learning how to name compounds. So we have three examples here at the moment. We have H2O, SO2, and P3N4. This is 4. It's, it's triphosphorus tetrahydride. So first, a simple rule of thumb here is that you look at the groups of the elements. We have groups. Group is increasing from left to right. So let us write first the element with a lower group number. So in this case, we have for H2O, we write the H first since the group number for hydrogen is lower than the group number in oxygen. So we write the first lower element, H2O. So H comes first since it has a lower group number. So you might ask, what if we have SO2 as in our example? So oxygen and sulfur are in the same group number or in the same column. So in this case, we will have to write or to look at the period number. So the period number is increasing. The period is increasing from up to down. Okay, so for S, sulfur, we will have to write the higher. When we look at groups, we will have to write the higher element, the element with a higher period number. So in this case, 16 is greater than, sulfur. This is 1, 2, 3, 4, 5, 6, 7, and 8. So 3 is greater than 2. So S, sulfur, is written first. We have followed by the lower period number, oxygen. So to remember, you just have to write when you're looking at group G, look for lower is written first. But when you're looking at the period, if some cases they are in the same column, you look at period and higher is written first. So I hope that's clear. So for another example, we have this P3N4. So let's look at phosphorus. We have phosphorus here, and N is also, or nitrogen is in the same column. So we will have to write P3N4 by looking at the period. Okay, we have written P first since it has a greater period number. So since we have two compounds, actually we have three. We have ionic, molecular, and metallic, but we are currently focusing on the two ionic and molecular compounds. So in naming molecular compounds, we only have to follow these four simple rules. We have one is to remove the ending of the second element and add IDE, just like in ionic compounds. So we will go in ionic compounds later part. So 2 is when naming molecular compounds, prefixes are used to dictate the number of a given element in a compound. So you use the mono, di, tri, tetra, penta, and so on. So it's all written here, and it's on your module also. And 3, if there is only one first element, you can drop the prefix. For example, CO is a carbon monoxide, not monocarbon monoxide, of course. So if the first and second element are single or mono, you only use mono for the second element in a compound. So fourth is if there are two vowels in a row that sound the same, once a prefix is added, so the extra vowel on the end of the prefix is removed. For example, one oxygen would be monooxide, but instead it's called monoxide. So the extra O is dropped. So we'll look at other examples. So I'm going to write some examples. We have the not so common ones. We have, as before, we have P3N4. We have N2O, P4, S10, and SF6. So in this case, we call this um, triphosphorus phosphorus tetra. Oh, I'm spelling phosphorus tetra nitride. Then we have this di, since it's two, dinitrogen nitrogen oxide. And then we have tetra phosphorus. 10 is deca sulfide. And SF6 we have, since it's 1, but we do not put mono since it's in the rule number 4. We do not put monosulfide sulfur, so we have sulfur. Some spell it like sulfur, but either way is okay. We have sulfur. 6 is hexa fluoride. So notice that we only change the last element, or the second element, its suffix to "ide." So the first element just stays the same. We just add some prefixes if they have uh, subscripts in their formulas. For ionic compounds, we name our compounds based on following these two simple rules. So the first one is the name should be first begin with the cation. It's positively charged ion, and then followed by the negatively charged ion or anion. So this is for ionic compounds. So rule number 2, this is for some cases, use Roman numerals if the metal ion has more than one charge. So I have this example from a video in Lumen courses. So these are his examples. We have Li2O. So this is actually named as. First, let's look at what lithium is. Lithium. So in our periodic table, we have lithium is a this lithium. L L L I L I. Ah, right here. So lithium is positively charged. So it is a cation. So lithium first. Lithium is said or put first. It's lithium. So the charge for lithium is +1. And so I'll just draft it right here. So the charge is 1. And oxygen is an anion. So oxygen is negatively charged. So it's -2. So the name for this is lithium oxide. Okay? So we have to balance this out since lithium is +1 and oxygen is -2. So we have to lithium +1 oxygen 2. So we have lithium 2O. So this will be the charge for this will be 0. Since we have +2 -2. So this is the ionic compound. So we wouldn't say that it's dilithium oxide since the 2 subscript here is essential when we balance this compound out. So this is a stable compound with 0 charge as a compound. So another example would be NH4 3P. So do not worry about this. It's just a polyatomic compound. So when we would say polyatomic, poly polyatomic ion is these are covalently bonded atoms. So we have this chart here. We have ammonium, hydronium, the most common positive polyatomic ions. So this is a one compound. It is a compound or ion with a single charge. So in this case, NH4 is an ammonia. It's positively charged. We have this ammonia, positively charged one, and phosphorus. So phosphorus is negatively charged, -3. So then we have a cation and an anion. So then we will call this ammonium phosphide. So since it's an ionic bond, again, we will be reading the subscripts here, unlike in the covalent bond. So another is copper, CuNO3 2. So let's just go back a little here. So we have ammonia, 3, and this is 1, positively charged. So the same thing happens, right? The same thing happened before. So we have this NH4. We treat this as an ion, which is positively charged, and phosphorus that is negatively charged. So we will have to have 3 here, superscript, subscript here. 3 times 1 minus 2 is 0. So this is a NH4 3 or ammonium phosphide. So this is a different case, okay? So let's look at copper. So copper is a transition metal. So we have discussed this before. Their charge may vary depending on what's needed, or they may have 2 or 3 charges. So copper here can be either plus +1 or +2 here. So we are not sure of that yet. So we will have to have it written first, since this is positive, this is cation, and we're looking for the NO3. This is nitrate, and nitrate is an ion. So let's check. Nitrate, NO3, NO3 here. This is nitrate. So we have NO3, and is charged negatively, -1. So this is the -1. And this one can either be +2 or +1. Okay? So what we're going to do here is use the +2 charge to balance it out. So we have Cu +2 as the superscript in the cation, and nitrate NO3 to -1. So for the charges, we have 2 plus -1 times 2. So this is 0. So this will become a stable compound. It's an ionic compound. So in naming, we will have finally copper 2, the Roman numeral, nitrate. So notice how we name ionic compounds and in polyatomic ions. So if we have a polyatomic ion here, either it's in first or second element, it remains the same. So this one is called copper nitrate. So it's not nitride, it's nitrate. Since it's NO3, this is fixed. This is a fixed polyatomic ion. So as so here we have ammonium phosphide. So the third example would be Ni2 So3 3. So let's examine this one. So we have Ni, this is nickel, and nickel is found somewhere. It should be positive. It's a cation, so we're looking for positively charged. So here it's nickel. So nickel is either +2 or +3. So we'll be contemplating on that. Nickel is either 2 plus or +2 or +3. And since this SO3 is SO3 SO3 is sulfide, 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 and it's negatively charged, 2 negative. Sulfide, it's SO3, and it's plus -2. The superscript is -2. So what do you think is appropriate here? So let's choose, so this is 6, and I forgot to put the subscript 2 here. We have 2, 3, 2. So we should have 6, negative 6. So we should have positive 6 on the cation element. So let's choose positive 3. We have, so the superscript would be 2 times 3 plus negative 2 times 3. This is 0. So then we will have Ni2 3 SO3 3 negative 2. The final for this is Ni2 SO3 3. This is a stable compound, ionic compound, and we will call this nickel or nickel 3. It's nickel 3 sulfide. So to check again, it is sulfide. And that's it.